In our final video, we're going to be looking at something called an inverting summing amplifier. This is certainly not an exhaustive treatment of every single type of amplifier we can make. However, the inverting summing amplifier is very useful to study because it can show us something that departs slightly from what we've already been doing. Before, we had only a single V-in, and we wanted an expression of this form. However, in this case, we have multiple V-ins, V1, V2, and V3. What we're going to get now, instead of that, is Vout is A1 V1 plus A2 V2 plus A3 V3. In fact, you can construct an inverting summing amplifier with as many inputs as you want. And Vout becomes the sum from I is 1 to n of AI Vi. It's a little bit easier to work with only 3 resistors, and so we're going to today. Now, the problem that we're having is that we have 3 independent input voltages. If you remember from last unit, when you have multiple voltages, you could analyze this entire circuit all at once. But a far easier way to do this is to use superposition. Superposition tells us turn off all inputs except for 1. Number 2, solve for Vout due to that input. Number 3, repeat for the remaining inputs. And number 4, add the outputs together. Let's go ahead and do that now. Let's say I turn off V2 and V3. Then turning them off means they're 0. And if I redraw my circuit, it's as though they aren't there. I have R1, Vout, and RF. Do you recognize this circuit? This is an inverting amplifier. So we already know what Vout is due to this. Vout, 1, the Vout due only to V1, is equal to negative RF over R1 V1. If we follow the exact same procedure for the other inputs, we're going to see we always get an inverting amplifier. Now, we can sum them together. Vout is going to be equal to negative RF over R1 V1 minus RF over R1 V2 minus RF over R3 V3. Oh, my apologies, that's R2 there. In the special case where R1, R2, and R3 are all equal, this expression simplifies. To this. So, it is an inverting, summing amplifier. the key takeaway was that we can use superposition in this case. It was far easier to use superposition than it would have been to do everything all at once. I encourage you to try it out. The other thing was that once we did that, we just recognized a common circuit, our inverting amplifier. So I'd like you to take away from this that if you look at an op-amp circuit and you recognize what it is, if you've already studied the fundamental amplifiers, then you can just start putting them together and doing some very interesting things.